last time on Monday, we talked about an idea, a construct in Java called type. And we talked about how when Java creates a variable for you, and we talked about how that variable holds particular kinds of data for you, that particular kind is a type that's assigned to that variable. And the idea of type is something that we're going to explore more today, and it's a very important issue that will have some subtleties that I think many people will have issues with. So the purpose of this lecture is to try to avoid any opportunity that you guys have issues with type. So be sure to ask questions and interrupt wherever you are concerned or you have some uncertainty, because I can assure you that types are a concept that people frequently have trouble grasping, not in the basic sense, in the sense that what is a type, but in the sense that types interact with all sorts of parts of the code, and people have issues with those different interactions. So we need to talk about that. So let's look at one of the examples that we talked about last time. The idea that we have these values stored into variables of a particular type, in this case, floats. And you can see that I'm performing some arithmetic on these values here, on my wallet total, dinner, and tip, and we're combining them all into this total dinner float, which is also of the same type. The fact that these are all the same type makes arithmetic really easy, because we don't need to think about what is happening with the types of these different variables. They're all the same type, and so operations don't require changes of type. Because remember, one thing that I said last time that I want to underline again here is that anytime we have a mathematical operation, plus, minus, multiplication, division, and other operations that we'll see in the future, anytime we have an operator that is operating on variables with a certain type, they must operate on two variables of the same type. If they don't get the same type, then there's a problem that can either be resolved automatically by Java or must be resolved by the program, in other words, you. So what we're going to talk about today is cases where Java can resolve type mismatches for you, and cases where Java cannot. Okay. And in order to understand this, we need to have a word, and that word is casting. Casting is the conversion of type from one type to another. And many people asked questions last time about how is it that these two things can be added together, with this int and this float can be added together, or how is it that they can't be added together? They were uncertain about what the conditions were or what exactly was happening there. Before we get into typecasting, I want to point out that that's exactly the right intuition that you should have. The intuition that you should have anytime you see a new Java construct that you feel something vague about or something uncomfortable about is that you should figure out what is the case that is weird, what is the case that doesn't seem to work or that seems to break the rules that you know. Identify that case and test it, or ask somebody that you know or Google it to see how that case actually plays out. So we're addressing that question now in the case of casting, and there'll be many other open questions that you guys have that we won't be able to devote the whole lecture to. So remember to Google and to ask people around you what happens when certain cases come up, because cases in Java happen all the time. So what we're going to talk about today is the conversion between integer and floating point types. So remember that floats and doubles are kind of the same thing. They all store numbers that have decimal values. But the difference between floats and doubles is that doubles have more memory to hold more precision information, more values after the decimal point. We're going to talk about how we deal with compiler errors that can occur when we read and see those compiler errors that come up, and you guys will see those in the lab on Friday. And we're going to talk about class and method structure, which you need to know about when we begin coding. So some of the other things that we'll cover today, you can see this list and we'll cover them. Okay, so what exactly is casting? Casting is a situation when a type cannot be converted to another type. And when we want to convert between those types, we can sometimes ask Java explicitly to make that conversion for us. Sometimes that conversion happens automatically, and sometimes we simply cannot convert between two types. Understanding when those three situations occur is crucial to understanding why some code might work and why other code will not compile or might work differently than you expect. Okay, so to give you some more terminology, these three cases are called the case of implicit casting. When you have implicit casting, then Java recognizes for you automatically that you, one, have different types that you're operating on, and that two, it can convert those types to be the same type before the operation actually occurs. And we'll see that in a second. The second case is the case of explicit casting, where you force one variable that you're operating on to have the same type as the other variable. But that requires the programmer to intervene specifically to say, I want this to be of a different type. Java does not perform that conversion for you automatically because that conversion might either lose data or change the way that your calculation might work otherwise. So it's like a safety mechanism to make sure that you don't develop strange bugs. And then finally, the case where, the case that I should have listed here, perhaps, is the case where simply the types cannot be casted to each other. So that's not a case of casting. You cannot cast between two types that cannot be transformed into each other. Knowing when that occurs and when it's distinct from implicit and explicit casting is crucial. Okay, so when does implicit casting happen? Implicit casting most frequently occurs when you have two numerical types of different degrees of precision. So far we have seen three different kinds of types that are numerical. We've seen integers, we've seen floating point values, and we've seen doubles. Integers have the least degree of precision because they don't store anything to the right of the decimal point. Floating point values store some values to the right of the decimal point. Doubles store twice as many values to the right of the decimal point. So in terms of the precision that can be represented by any number, you have greater precision, greater significant figures that can be represented by doubles, less by floats, and even less by integers. So implicit casting occurs when you perform a mathematical operation between a higher precision numerical value and a lower precision numerical value. So if I attempt to add an integer to a float, then Java will automatically convert that integer into a float and then add the two together. Because remember, that operation cannot occur unless the two values are made to have the same type. Okay, so we can see an even simpler example of that here with this example. Float x equals 3.2. The error that we get when we attempt to compile this, and you will see examples of this in the lab on Friday, is this type mismatch. It will say, the Java compiler will say, cannot convert from double to float. And what that means is, remember what's happening in this line, it's attempting to store the value 3.2 into the variable x. Because remember, the assignment operator always takes what's on the right and stores it into what's on the left. By attempting to add 3.2 into this variable, what it's actually doing is attempting to take this double 3.2 and store it into this variable. So what we're realizing here, I guess, as a class, is that anytime we see a decimal value, 3.2, 3.5, that value is interpreted as a double. It's not interpreted as any floating point value. It's always interpreted as a double. So this number here has a type. It's not simply a number. We'll talk about exactly what it is in even more detail later, but this is a number and it has a type, and that type is double because it's a decimal value. Attempting to take this double and store it into this float is a type mismatch because they're not the same type. You can't store doubles into floats. And in particular, the double has greater precision than the float. And so it cannot be implicitly casted to store into that floating point variable. I see a lot of puzzle books in the audience. Yes?
Was there ever, I'm trying to think of how to phrase this. If you just set everything to double, you know what I mean? Would that be a problem, like, since it seems to encompass everything else?
That's a great question. So the question is, to rephrase it, what if I made all of my mathematical operations in doubles instead of something else? Then wouldn't that just get rid of this whole precision casting issue? Like, why would I have to think about that if I just made everything a double? So in principle, you could, but that has some penalties. So if you were to do that, then you would use more memory because things that only need to store integer values now have to store more memory. And also, you would create situations where mathematics on doubles, which because they have such great precision, actually have some mathematical consequences to them, can lead to some imprecision later on. And we can talk about that later. But because of the way doubles represent numbers, you get precision in some parts of the real number line and a lack of precision elsewhere. So there are actually mathematical reasons why you might want to select integers and not doubles sometimes, especially when you're doing very integer-y things. Yes?
Oh no, I thought that floats also had decimal points.
Floats also have decimal points.
Okay.
The difference is that floats store less digits of precision than doubles. In fact, they store half as many digits of precision.
I just don't understand how 3.2 can be a float.
So that's a great question. So the question is, I don't understand how 3.2 cannot be a float. 3.2 can be a float. It's just that the way that the characters are interpreted by Java is always to assume that anytime you write a literal number in the code, when it has a decimal point, to always interpret it as a double. So Java, anytime you write a decimal value, Java will always interpret it as a double, unless you tell it otherwise. And we'll see in a second how we tell it otherwise.
I think that sort of answers my question, but how would you ever set a float value if Java assumes that any decimal type is a double?
I'll show you that in a second.
Kind of the same question.
Okay, so the question was, how would you make this a float if this is always interpreted as a double? And I guess by translation from that question, how would you ever make any value a float if you can't make it a float somehow if it's always interpreted as a double? We'll see that in a second. So there is implicit casting going on all the time. And implicit casting happens when we make automatic conversions between types. And sometimes we have explicit casting. Do I have a... When we have explicit casting, when we say, I must convert this value into this other value, I know it's possible to make that conversion. Make that conversion for me, please, Java. Thank you. So here is a great example of that. And it's sort of on a different slide that I would have referred to, but just so that we can address this question right now. Let's suppose we had this code here, right? 3.2 is considered a double by Java. How do I make it a float? So the way I can make it a float is that I can perform an explicit cast. This is different from implicit casting. I can make it explicit cast, which is literally writing the word float in parentheses to the left of this number in order to tell Java, please convert this number into a float instead of letting it be at the double that you think it is. And what this is doing is it's saying, when I put this word in parentheses here, it's saying, take the thing immediately to my right and make it the type that I specify here. That's an explicit cast. So the purpose of explicit casting is that explicit casting avoids mistakes that might occur in precision by forcing the programmer to say that they actually want this deliberately. So it's a way of requiring confirmation from the user. And there are good reasons for wanting this. So why is it that we might want to insist that the programmer demand that they have a float instead of the interpreted double? Well, the double stores many more digits of precision, right? So that's the difference between pi being 3.141592 something something and being 3.1. There's differences there because when you perform calculations with those different decimal values, you have greater precision with the longer decimal value. So, okay, floats store more than 3.1. I'm giving you a simplified example because I don't know that many digits of pi. But your advantage is the same, that you get to have greater precision if you work with doubles. And if you lose that precision by deliberately converting that value into a float by performing the explicit cast, then Java is going to ask you for confirmation. It's going to say, well, I'm only going to let this compile if you say you really want this. And the way that you say that you really want this is to demand that this value be the type that you say that it should be. Yeah.
So to make the equation on the last line work, could you just write float x equals parentheses float 3.2?
Yes, so to make this work, because 3.2 is interpreted as a double, we would have to add parentheses float here, float x equals parentheses float 3.2. And that would take the 3.2, it would convert it into, which is a double, it would convert it into a float, and then it would store it into that variable. So see how that explicit casting happens. It's a way of inserting an additional step into the way this code is interpreted. I have 3.2, I'm converting it into a different type, and then I'm storing it. In this line here, I don't have that conversion. I just say, I attempt to take 3.2 and store it directly, and that doesn't work. But when I have the float in parentheses here, which is the explicit cast, I have the 3.2, I had this additional step where I convert it into a float, and then I store it into R1. Question? Your name, please?
JC.
JC.
So I don't get why you would use like a float if double has more precision.
So you would use a float even if doubles have more precision because floats save you half the memory that doubles have. So it doesn't matter right here, but in a great example is in when you're doing sort of data science and big data things. If you're not recording that many digits of precision, or you know that some digits of precision are noise, like values that you're getting off of your giant telescope has many digits of noise in it, then you don't want to record those anyway, and you could save space on your disk. So it could mean that you can record the solar eclipse for longer, for example. Greg, question?
Yeah. So once you do the explicit casting with floats, can you then just like, if you want to do like math with it, you can just start doing, like if you typed in float variable 1 plus whatever you wanted to add it with, would it work now that you just did the explicit casting?
You mean now that the value has been stored into var1, that can you use it in the future as a float?
Yeah.
Yes, you can, because whatever has been stored into var1 has to be a float. And so we've sort of forced the square peg into the round hole through explicit casting and made this into a float and stored it into var1. So thereafter, var1 is still holding only float data. It only ever will hold float data. And so that's why it's not an issue. Anna?
Oh, I was just gonna ask, are the quotation marks, is that adding a space in? And then
We'll talk about that in a second. Yes, your name?
Brett, like, if Java assumes that every decimal is a double, like, why do you even have to name it a double? Like, what if you just wrote var2 equals 3.3? Wouldn't it just assume it was a double?
That's a great question. So why do I have to declare var2 as a double type if all decimals are interpreted as doubles? The answer is not because in some sense that you need it, like that this line needs it, but it's because Java as a language demands, well, programming languages as in general demand uniformity. So the way that this is interpreted, you have a variable that has to have a type. Before it considers what it's going to store into it, you have to have a variable, it has to have a type. Well, you have a variable, it has to have a type. So before it even considers what will be stored in it, you must define a type. So you could say, well, in hindsight, after you read the entire line, that 3.3 is a double, and that should imply that var2 is a double. There are, in fact, programming languages that are flexible in this sense, that before you store something into the variable, it doesn't care what the type is until the first thing that gets stored into it. Python is a great example of that.
So, to be clear, like, would that give you an error if you didn't call it a double? If you
Yes,
just,
yes, it would, because you must always declare the type of a variable when you declare it. There are more hands, but they're not open. Okay. So let's look at other examples of implicit casting. So you will see in the near future other types. So we've talked a lot about floats and doubles because they're great examples, but there are also integers and Boolean values. Like Boolean values store true and false only. And a nice different category of types to be aware of are chars and strings. So strings are literally lists of characters, and they hold like sentences and words, and they differ from chars because chars are characters, they only hold one letter or character. So it's useful to know about chars and strings because we frequently perform string-based arithmetic. And what I mean by string-based arithmetic is that we do things with strings that make a lot of sense, that require us to have an arithmetic for them. So what you can see in this line here, system.out.println, which is printing out a string. We're adding a series of variables, the variables that we created here. We're adding them together, and the operations that we have here are very strange if you consider the types of these variables, right? var1 is a float, but doesn't system.out.println take a string? Like what's going to happen there? var2 is a double, and there's these quote things in between them. Like what's going on there? So let's see exactly how this works. So this code is correct Java. This works. This runs. Java insists in the system.out.println command that you give it a string. Because what system.out.println does is it accepts a string and prints it out to the screen so that you can see it, or whoever's running the program can see it. You will write system.out.println commands in the lab that you have on Friday. Instead of a string, though, it's getting a float plus something in quotes, plus a double, plus an int, and so on with these things in quotes. Now, what the thing in quotes is it's a string. A string is another type here that I haven't defined anything as because I'm just adding it explicitly in quotes. So just like you have the number 3.2 or the number 1, the way that you can define a literal string, just like these are literal floats, is by putting something in quotes. So what I have here is a float plus a string, plus a double, plus a string, plus an int, plus a string, a boolean, plus a string, plus a char. That still doesn't make any sense, right? Because now I have a whole bunch of additions between things of different types. So that's really strange. But a second important fact to know about the primitive types of Java is that they can all be implicitly casted into strings. And this is really nice because sometimes we need to be able to print out values to the screen so that we can see what's wrong with our code. So var1 can be implicitly converted to a string, but before I can convert var1 to a string, I need to perform this addition. I need to figure out the entire thing inside these parentheses before I do the thing that's outside the parentheses. Just like in mathematics, we do everything inside the parentheses before we do everything outside the parentheses. So how does this work? Well, we add the space to var1, and we have a float in var1, and we have a string in this space. And because a float can be implicitly casted into a string, we first convert var1 into a string, and then we add it to the space. So var1 holds 3.2. When we implicitly convert it into a string, it becomes essentially quote 3.2. It becomes the characters 3 period 2. And when I add a string to a string, I get a space, I get the two strings concatenated together. So that this little part here becomes 3.2 space. And so this whole thing, the first two items of this addition, those are string. That's a string. That entire thing is one string now. When I add that to var2, Java implicitly converts var2 into a string. And so it becomes quote 3.3. And when I add 3.2 space 3.3 together, I get the single string 3.2 space 3.3, all in one string. And that's all one string now, so when I add it to the space here, I get 3.2 space 3.3 space. And you can see how this addition systematically adds all of these other types together and creates a single string, because it forcibly, it implicitly casts all of those different types into strings as it goes. Because each time you have a string and you have some other value, and the only way to make those the same type is to convert the other value into a string. Your name and your question?
Charlie, and if you didn't have the spaces there, would you still know to convert it to a string?
That's a great question. So if you didn't have the spaces here, would it know that the entire thing inside the parentheses would become a string? You wouldn't know until the very end, and it wouldn't be able to implicitly cast all of those things together. So you cannot implicitly cast, say, the double to a char, or the int to a double, or any of these things. So because these variables do not implicitly cast to each other, then that addition would result in a compiler error saying type mismatch. These are different types. I don't know what to do with them. But because we're performing additions with the string, the space string in this case, and because everything can implicitly cast into a space, then we can take each one of those things and implicitly cast them into a string and slowly glom this all together into one long string. Great question. Yes.
I'm
Your
Sammy.
name, by the way?
Sammy.
Sam?
And didn't you say before that ints implicitly class to doubles and floats implicitly class to doubles? So if you just added together ints and floats and doubles, when they all cast to doubles and add together?
Yes. If these were all ints, floats, and doubles and nothing else.
Oh, so the character is what messed it up?
Yes, and the Boolean is what messed it up. So if these were all ints and floats and doubles, they would all basically turn into doubles at the end. So even if we started with ints adding to floats, then it would turn into a float, and then after you saw the first double, it would all turn into doubles, and so on and so on. So you can think of strings as sort of like that whatever it was, when you attempted to add it to a string, it turned into a string, and then it stayed a string. It can't convert the string backwards, so then it continues to convert everything into a string and put it together. Yes. Your name?
Claudia.
But
So when you're typing in the, I guess it's in the parentheses, you have to write var1 and then space plus, like, and then you just keep doing spaces in between everything, or like, where how do you know exactly where your spaces are supposed to go?
that's a fantastic question. I'm glad that you asked it because it's a detailed question that I accidentally glossed over. So var1 is a variable, we know that. And we know that we're adding it to something, so there's that plus, but what's exactly the deal with the spacing that I have here? So you can have an arbitrary number of spaces between a variable name and anything else. So there can be spaces between the parentheses and var1 or var1, and you can have spaces between var1 and the plus. The plus could be right up against var1 also, you don't have to have the space there. And the plus could also be right up against these quotes. But the quotes are a thing, and what is between those quotes is exactly what that string is. So if it's just space, then it's just exactly one space there. But if that string was a word like Lehigh or a word like something else, it would have to literally say L-E-H-I-G-H with no spaces in between the quotes. But then if you think about the thing that we're adding together as a series of items, where some are strings and some are variables, then an arbitrary number of spaces can exist between the variables and the operators, which are the pluses.
So you actually want to put a space in between the two quotations to hold, is that like?
Yes, that's intentional because the space between the quotations is literally the space that I'm adding here between 3.2 and 3.3, or here between 3.3 and 1. Yeah, because the output, I hope that goes away. The output is literally the things at the bottom of the screen. var1 is 3.2, var2 is 3.3, var3 is 1, and you can see how that is on the bottom of the screen. It's 3.2 space, 3.3 space, 1 space, true space, C. Yes, what's your name? Jake.
So for whatever reason you wanted to print that out without spaces, would you just put two sets of quotes right next to each other with nothing in between them?
That's a great question. So we know that we can't get it all to work without the quotes, right? Because then we have the implicit casting problem that we just talked about. But if we don't want to have the spaces, then what do we do? What you could do is, so I do believe you could have the quotes with no space. But that's kind of ugly, right? Because it's sort of like an artificial thing there that you don't really want to have. If you want it to be clever, what you could have is an explicit cast of var1 into a string. So here we're explicitly casting into a float. But we could explicitly cast var1 into a string. And just say, like, Java, make this into a string, because I wanted a string. And what would happen there is that once var1 is interpreted as a string, that addition to var2, since there's no space, would be a string plus a double, and that would convert into a string. And that would set off the same thing that's occurring here with the quotes, except that you wouldn't have to add any of the non-space space strings there. Yes. Your name?
Will. Do Booleans convert to like 0 and 1?
Booleans do not convert to 0 unless you explicitly convert them into a string, into an integer. Excuse me. Yes.
Can you?
I've forgotten your name.
Patrice.
Patrice.
Can you assign just a number to a string, or do you have to explicitly cast it?
You can assign a number to a string. Like if I have a string variable, I could say string my variable equals quotes 2.5. But what distinguishes a number interpreted by Java like this as a number and what's interpreted as a string is the existence of the quotes. So if I wrote int var3 is equal to quote 1, then that's going to be like you're trying to store a string into an integer. That doesn't work. Yes, your name?
Mary. For the character, are you saving that not as a string for the sake of memory also?
Yes. I am storing characters not as a string for the sake of memory, to save memory, but also sometimes we want to represent variables as letters that we can operate on. And a cool thing about characters is that you can actually add a character to a character. Like you can add lowercase a to lowercase c, and that will give you a different character. I think it's like F or something like that. And there's a bizarre mathematics of that, which is sometimes helpful if you want to iterate on characters. So it's like if you want to do like things that move in order of alphabetical order, you can do like a kind of a funny mathematics on characters in that way. So that exists in some sense because you want to save memory, and also because you might want to take advantage of that. And that's a very unusual thing, but it's there. Okay. I'm really great that we got all those questions out, because we got to talk about a lot of the things I was going to talk about. So now we should understand the idea of explicit casting. Explicit casting only happens when you have this parenthetical expression here. And that parenthetical expression only applies to the thing immediately to its right. It always converts the type of the thing immediately to its right. And without it, you can't convert some types to others. Now, there are things which cannot be even explicitly cast. There's some things that cannot be explicitly cast, even if you want to convert them. So here's a great example. If I have a string called myString, and I've assigned it to OMG, then attempting to convert that to a double and store it into this new double variable will not work. So myString is a string, and I just can't turn whatever those letters are into a double. And even if I stored in the string variable a quote-unquote number, right? If string myString was equal to quote 2.5, I still couldn't give it this explicit cast to say convert that string into a double and store it into this double. That's counterintuitive because it seems like, oh well, computers should be able to figure out what number that is. Absolutely, absolutely. But you don't do it this way. You don't say, Java, please do this conversion for me. You have to use a little program that will do that conversion for you. And I'll show you how to do that conversion. But in terms of the language constructs, the language will not let you take a string and convert it into a double. You have to do much more special things to do that. And not that they're so special, but you have to do something different. It's not supported inside the language. Correct.
Is it possible, what if you turn a double into a string and then realize you don't want it to be a string anymore? How do you get it back to being a double? Or
you can't convert it back. Yeah. So turning doubles into strings through explicit casting or implicit casting is easy. The reverse conversion is not possible unless you do some special stuff, which is out of the current context. Okay.
Can you convert a string to anything, like anything else?
You cannot convert a string to anything else either. Okay, so when you attempt to perform an explicit cast, which is not possible, you get this command. You get this error here, cannot cast from java.lang.string, which is the string type, into double. So anytime you perform an illegal explicit cast, you'll see that error. Okay, so a second important topic that I wanted to talk about that we didn't totally get to hit today is a relation, well we did partially, is a relationship between casting and arithmetic. So to get you thinking about this, let's look at this example here. Suppose I have double my double 1 assigned to 3.2, another one assigned to 4.5. If I add these two things together and assign it into this integer, what's going to happen? Does anybody want to tell me what's going to happen? Yes. Your name?
Jason.
Jason.
You're going to record my double 1 as an integer, and then it's going to be weird because the plus my double 2 doesn't make sense.
You're almost there. You're almost there. Does anybody else want to take a crack at it? In the back?
It's going to take the my double 1 and turn it into an int, and then it's going to add that to the double, so you're going to get an answer of 7.5.
You're overlooking a step, and that's leading you slightly astray. But It's not, you had the conversion correct, yes?
It won't compile because in my val is an integer, and you're adding an integer to a double, so the answer should be a double.
Good, that's correct. So let's review the steps that are happening. What was your name?
Spencer?
Spencer? So let's review the steps that are happening here. And Kai, you had the first step right, but your interpretation of the second step wasn't clear, and that's fine because I haven't told you the second step yet. The first step is that we will convert my double 1 into an integer. And we're familiar with that idea because we're making that explicit cast. Now we have an integer plus a double, right? So remember that thing that I said about how every time we have an arithmetic operation, that we have to have the same type on both sides of that operation. So here we have an integer and we have a double. What's going to happen here? Well, Java can implicitly cast integers into things with higher precision. It can convert floats into things with higher precision also. So when that integer and that is added to that double, Java says, oh, okay, well I have a double and I have an integer. Implicitly cast that integer into a double so that they have the same type. So that explicit cast that's written here gets reversed and my double gets turned back into a double so it can be added to my double 2. And then I have these two things added together, the sum of which is interpreted as a double, because when we add two doubles together, we get a double. And then we attempt to store that double into the myval variable, which is an integer. And we can't do that because we don't have an integer on the right-hand side, we have a double. So that's why this results in a compiler error, which says that, hey, you're trying to store something of the wrong type into the integer. Now, this can be resolved by a number of different ways so that it will compile. But it's important to understand the consequences of what exactly this code is doing here. So casting has a particular syntax. And that syntax is that the thing to the right of the casting operator has greater precedence than the mathematical operations. So, as I said earlier, that explicit cast happens to the variable immediately on the right. So, if I want to convert the entire thing into an integer, then I can't do this because this is only going to convert my double 1 into an integer, which is promptly going to be converted back into a double because my double 2 is a double, and you can't add an integer to a double without implicitly casting the integer. So, if we want to fix this problem, what we need to do is we need to add parentheses. If we add these parentheses here to the sum my double 1 plus my double 2, what Java will do is first perform the addition of the two doubles. So we have a double inside this parentheses. And then we convert that double into an integer. And then we can store it into my double. So in this new version, what we have is we have a situation where we have produced something on the right that is actually an integer that can actually be stored, whereas in the previous version, we had an integer here that was converted back into a double, and then the entire thing resulted in a double that could not be stored. Yes?
Shane, and even though it would be a little more exciting, could you also add an int in parentheses before the my double 2?
That's a great question, Shane. Yes, you could explicitly cast my double 2 into an integer, making it an integer plus an integer, which would then be stored correctly into the variable my double. Yeah.
But can't you store a number with a decimal next to 7.5 as an integer?
So you cannot store a double value into an integer, and that's why the original version has a compiler error, because it's a double and it can't be stored into it. You can convert the sum of the two values into an integer and then store the integer, but that's the different value. So the other important thing to know is that when we convert that sum into an integer, it's an integer, right? So 3.2 plus 4.5 is 7.7, right? When we convert 7.7 into an integer, that doesn't get rounded. that's going to be truncated, which is a new idea that I want you to know about. When I convert any floating point value into an integer, I cut off the decimal values. I truncate it into an integer. And in fact, if I convert a double into a float, I actually truncate some of those decimal values that aren't stored by the float when I convert the double into a float. But in this case, when I convert 7.7 into an integer, I'm getting 7. So this value here turns from 7.7 inside the parentheses. After the explicit cast, it becomes 7. And the value stored into myval is equal to 7. The typical expectation is that it would be rounded because it seems like it would be the more precise thing to do. Java doesn't round for you. If you want to have a mathematical round happen, in other words, if it's greater than 0.5, make it the next higher integer. If it's less than 0.5, make it the next lower integer. Then you need to call a special function which will convert it to the correct integer before you store it as a rounded integer. But right now, since we're not doing that, you just truncate off everything after the decimal point and store it as an integer. Yes?
So if
I forgot your name.
my name's Christian.
Christian.
If you use like the initial one, like integer my_1 plus integer my_2, and then you had for my_1 3.7 and then I guess 4.7, would it be 4 plus 4 or would it be like I guess 9?
Okay, so the question is if this was 3.7 and 4.7 and we performed 2 explicit casts, right?
Like the parentheses matter, like do they change in the order that it's truncated?
Yes. Yes, so that's absolutely correct. So Christian's asking, does it change the order in which the truncation happens? Yes. So if my_1 is explicitly cast int and my_2 is explicitly cast int, then this becomes 3 and this becomes 4, and the 2 get added together into myval as 7. So you can imagine situations where you have a lot of things equal to something 0.9, something 0.9, something 0.9. And if you independently truncate all of them, you lose actually a lot of that value. So there are ways to generate mathematical inaccuracies when you explicitly cast, because you're losing data. Okay, so the crucial thing in the last 60 seconds that we have in the class, the crucial thing that I want you to know is a new skill that you must master. And that skill is figuring out the order of evaluation in arithmetic and other Java operations. So when you understand the order of operation, you understand what values get converted into what types, because it happens in a certain order. That's what we're seeing here, that if we don't know the order of evaluation, then we don't know what the types are, and we can get surprise type mismatches that make our code not work. So this is the sort of thing that I can easily test you on, where it's like, here's this long expression. Tell me what type you get at the end. Or what type is it after you get this parentheses? You need to be able to understand what is the order of evaluation that Java performs, and what is the type at every point along that evaluation. Okay? So we'll see some of that in the lab.